Hello, this is Sheikh Maulali MA Ahmed. In this session, we are going to discuss about atomic clocks, how atomic clocks replaced to the quartz oscillators. How precise do they get? In the present situation, we need clocks that will keep time to a very high accuracy. The answer to this requirement is the atomic clock. The previous generation of clocks, which consisted of a quartz crystal oscillator, was performing efficiently, but the best of such oscillators would be late by a nanosecond after an hour of efficient performance. Translate this into distance measurements. Translate this into distance measurements made with the help of clocks and you have a more tangible error. In a matter of 6 weeks, this would translate into an error in measurement of distance by 300 kilometers. So, if this clock were used to gauge the position of a spacecraft, it would be very prone to error. To prove on this, atomic clocks were invented. To improve on this, atomic clocks were invented. If we speak roughly, an atomic clock contains an element like cesium or calcium and a source of microwave radiation. Atoms consist of nucleus, which has protons, neutrons, and these are surrounded by a cloud of electrons, which occupy discrete energy levels of states. When excited by a microwave, the electron in the cloud can absorb some of the incident radiation and get excited to a higher excited state. But for this but for this to happen, the incident microwave radiation must match the characteristics frequency of the cesium or calcium atom. By tuning the microwave source and observing at what frequency the transition takes place, the exact value of the characteristic frequency is calculated, and from this, the time can be measured accurately. Frequency refers to the number of waves that cross a particular point in time in one unit of time. From this definition, by counting the number of waves, the time can be measured. NASA's Deep Space Atomic Clock misses a second once in 10 million years. The official definition of a second today is given by the frequency needed to make electrons transition between two levels in a cesium atom. But the state of the art is strontium clock that loses 3.5 bits only once in 10 quintillion bits. A quintillion in 1 followed by 19 zeros. Please subscribe my channel. Thank you.